Probabilities using counting techniques. In the first example, we use permutations. Two brothers enter a race with 5 friends. The racers draw lots to determine their starting positions. What is the probability that the older brother will start in lane 1 with his brother beside him in lane 2? So ultimately, the information we need for probability is we need to count the number of times it's going to occur. So the number of times it's going to happen over the number of times it could possibly occur. So first things first, let's find the complete set. So the number of items in the set would be 7p2. There are 7p2 times that 2 people can start first and second. So that number is 42. The number of times those first 2 positions can be filled. The number of times that the brothers will start side by side with the older first and the younger second would be 1 time. So therefore, the probability of this occurring would be 1 time out of 42. So that's the probability. If you wanted to convert that to odds, that would be 1 against 41. And now an example using combinations. A focus group of 3 members is to be randomly selected from a medical team consisting of 5 doctors and 7 technicians. That means we have a total of 12 people. What is the probability that the focus group will be comprised of doctors only? There are 5 doctors. So for question A, let's figure out the number of times we can select the doctors. We have 5 doctors, and we want to select 3 of them. So 5 choose 3, which equals 10. We're going to select them from a possibility of 12 choose 5, which is 220. So the probability of A occurring, doctors only, would be 10 out of 220, which will reduce to 1 out of 22. Incidentally, the odds of that happening would be 1 against 21. Now, what is the probability that the focus group will not be comprised of doctors only? So we're trying to find the complementary event. So complementary event is denoted like that. And that event is 1 subtract the event of it actually happening. So this will be 1 minus 1 over 22. So the complementary event would be 21 out of 22. So there is your complement. Now the odds of that occurring are 21 to 1. So the odds of that occurring are pretty strong. And now lastly, the probability using the fundamental counting principle. So what is the probability that 2 or more students out of a class of 24 will have the same birthday? Assume that no students were born on February 29th. That means we have a year comprised of 365 days. Now it's going to be easier to find this by the indirect method. So let's find the event of no people having the same birthday. So no same birthdays. All right, I'm going to make a little chart. So we have students. And we have 24 students in the class. So 1, 2, 3, 4, way down to 24. Now, the odds of no students having the same birthday. No students, same birthday. So, looking at the second student would have 364 days of the year without the same birthday as the first student. So I'm just comparing the first two students in the class. So again, the second student would have 364 days without the same birthday. The third student would have 363 days without the same birthday as the first two. The fourth student would have 362 days without the same birthday as the first three. So ultimately, when you get down to the 24th student, the 24th student would 342 days without the same birthday as the other classmates. So to come up with that number, you take your 365, that's the possible number of days, subtract 23, not 24, because we're not counting the first student. And that leaves us with 342. So that's where I get that final number. And now, when I multiply all these things together, because we're talking about an and situation, that will be approximately 0.462. So this is the probability of it not happening. So the probability of it actually happening would be 1 minus the probability of it not, the complement. And so when you do that math, it's 1 subtract 0.462, and that will get you to 0.538. So the probability of 2 or more students out of a class of 24 having the same birthday is 53.8%. Thanks for listening.